Section 1.7, Architectures for Cloud-Native Applications. We have reached the last step of our journey to define cloud-native, and I've introduced the primary characteristics we'll rely on throughout the book. In the previous section, you got familiar with the main cloud-native topologies, particularly containers, which are our computation units. Now let's look at what's inside and explore some high-level principles involved in architecting and designing cloud-native applications. Figure 1.12 shows the main concepts covered in this section.
Figure 1.12, Cloud-Native Architectural Elements.
Section 1.7.1, From Multi-Tiered to Microservices Architectures and Beyond. IT infrastructures have always affected the way software applications are architected and designed. In the beginning, monolithic applications were deployed on huge mainframes as single components. When the Internet and PCs became popular, we started designing applications according to the client-server paradigm. A multi-tiered architecture, relying on that paradigm, was widely used for desktop and web applications, decomposing the code into presentation, business, and data layers. With the increase in application complexity and the need for agility, new ways of further decomposing the code have been explored, and a new architectural style entered the stage: microservices. In the last few years, this architectural style has become more and more popular, and many companies decided to refactor their applications according to this new style. Microservices are usually compared to monolithic applications, as shown in Figure 1.13.
Figure 1.13, Monolithic Applications versus Microservices. Monolithic architectures are often multi-tiered. Microservices are made up of different components that can be deployed independently.
The main difference lies in how the application has been decomposed. A monolithic application is associated with using three large layers. A microservice-based application, in contrast, is associated with many components, each implementing only one piece of functionality. Many patterns have been proposed to decompose a monolith into microservices, and to handle the complexity created by having many components instead of one. Note: this book is not about microservices, so I won't go into detail about them. If you are interested in the topic, you can check out Building Microservices, 2nd ed., by Sam Newman, O'Reilly, 2021, and Microservices Patterns by Chris Richardson, Manning, 2018. For a more Spring-oriented analysis, you can find Spring Microservices in Action, 2nd ed., by John Carnell and Hilary Huilupo Sanchez, Manning, 2021, in the Manning catalog. If you are not familiar with microservices, don't worry. That knowledge is not required to follow along with this book. After many years of fame and failed migrations, intense discussions about the future of this popular architectural style have arisen in the developer community. Some engineers started talking about macroservices to reduce the number of components, and therefore, the complexity of managing them. The term macroservices was suggested sardonically by Cindy Sridharan, but it has been adopted in the industry and used by companies like Dropbox and Airbnb to describe their new architectures. Others proposed a citadel architectural style consisting of a central monolith surrounded by microservices. Still others are advocating a return to monolithic applications in the form of modular monoliths. In the end, the important thing is to choose an architecture that can deliver value to our customers and our businesses. That's why we develop applications in the first place. Each architectural style has its use cases. There is no such thing as a silver bullet or one-size-fits-all solution. Most of the negative experiences related to microservices were caused by other issues, such as bad code modularization or unfitting organization structure. There shouldn't be a battle between monoliths and microservices. In this book, I'm interested in showing you how to build cloud-native applications with Spring and deploy them to Kubernetes as containers. Cloud-native applications are distributed systems, just like microservices are. Some topics usually discussed in the context of microservices actually belong to any distributed system, such as routing and service discovery. Cloud-native applications are loosely coupled by definition, and that is also a feature of microservices. Even if they have some similar aspects, it's essential to understand that cloud-native applications and microservices are not the same. You can definitely use a microservices style for cloud-native applications. Many developers do, but it's not a requirement. In this book, I will use an architectural style that we might call service-based. Perhaps it's not a catchy name or a fancy one, but it's enough for our purpose. We'll deal with services. They can be of any size, and they can encapsulate logic according to different principles. That doesn't matter. What we want is to design services to fit our development, organizational, and business needs. Section 1.7.2. Service-based architecture for cloud-native applications. Throughout this book, we'll design and build cloud-native applications according to a service-based architecture. Our central unit of work will be a service that can interact with other services in different ways. Using the distinction proposed by Cornelia Davis in her book Cloud Native Patterns, Manning 2019, we can identify two elements of the architecture: services and interactions. Service, a component that provides any kind of service to another component. Interaction, the communication of services with each other to accomplish the system's requirements. Services are quite generic components. They might be anything. We can classify them according to whether they store any kind of state, distinguishing between application services, stateless, and data services, stateful. Figure 1.14 shows the elements of a cloud-native architecture. An application used to manage the inventory for a book library would be an application service. A PostgreSQL database used to store information about the books would be a data service.
Figure 1.14. Service-based architecture for cloud-native applications. The main elements are services, application or data, that interact with each other in different ways.
Application services. Application services are stateless and are responsible for implementing any kind of logic. They don't have to obey specific rules like those for microservices, as long as they expose all the cloud-native properties you learned about earlier in this chapter. It's paramount that you design each service with loose coupling and high cohesion in mind. Services should be as independent as possible. Distributed systems are complex, so you should be extra careful during the design phase. Increasing the number of services leads to an increased number of problems. You'll probably develop and maintain most of the application services in your system by yourself, but you can also use some offered by cloud providers, such as authentication or payment services. Data services. Data services are stateful and are responsible for storing any kind of state. The state is everything that should be preserved when shutting down a service or spinning up a new instance. Data services can be relational databases like PostgreSQL, key value stores like Redis, or message brokers like RabbitMQ. You can manage these services by yourself. Doing so is more challenging than managing cloud-native applications due to the storage required to save the state, but you will gain more control over your own data. Another option is to use the data services offered by a cloud provider, in which case the provider will be responsible for managing all the concerns related to storage, resilience, scalability, and performance. In this case, you can take advantage of the many data services explicitly built for the cloud, such as Amazon DynamoDB, Azure Cosmos DB, and Google BigQuery. Cloud-native data services are a fascinating topic, but we will mainly deal with applications in this book. Data-related concerns like clustering, replication, consistency, and distributed transactions will not be detailed too much in the book. I would love to, but they deserve their own book to be adequately covered. Interactions. Cloud-native services communicate with each other to fulfill the requirements of the system. How that communication happens will affect the overall properties of the system. For example, choosing a request-response pattern, synchronous HTTP call, over an event-based approach, messages streamed through RabbitMQ, will result in different levels of resilience for the application. In this book, we'll use different types of interactions, learn the differences between them, and see when to use each approach.